So now to this last situation. We have four terms, and so the first thing we try to do is we try to factor by grouping. Unfortunately, this doesn't work here. The x minus 6 is not the same as 9 minus 49y squared. So what we have to do is use an alternative strategy. What I'm looking for is I'm looking for a perfect square. I'm looking to factor three terms and get a perfect square. And you'll see why in a moment, because it's actually going to form a difference of squares. So x squared minus 6x plus 9, this is a perfect square. And so I'm going to write this out in the form of a squared minus 2ab plus b all squared. And so you can see the a term is x and the b term is 3. And then we still have the minus 49y squared at the end. Now, in this case, it's a minus sign before the second term. So instead of the plus before the 2ab, it just becomes minus. And so that's the only thing that changes is the negative sign between the a and b when you go to factor it. So that gives us x minus 3, a minus b, x minus 3 all squared, minus 49 squared. That's your b term. It's your second term. And so those are two terms, x minus 3 squared and 49y squared. What I can do now is I can write that out as x minus 3 squared and then the 7y all squared. And so your a term is x minus 3. Your b term is 7y. And remember, for a difference of squares, we write that as a plus b times a minus b. So we write the x minus 3, that's the a, plus 7y, that's the b, and then x minus 3 minus 7y. And so what I'm going to do now is I'm just going to rearrange that. We generally write x, then y, then any non-variable term last. And so I just am switching the order of the negative 3 and the 7y, and then the negative 3 and the negative 7y in the second brackets. And that is your final answer.